Warning, this video is intended for a mature audience. You understand? Viewer discretion is advised. Yay! Alright, this is Billy Bob Tanley here, people, and this is a request from a person calling themselves Yay, and it was uploaded by the Organic Chemistry Tutor, and name this video is Understand Calculus in 35 Minutes. Okay, let's check it out. Yay!
In this video, I'm going to attempt to teach the fundamentals of calculus in a very short time. So there's three areas of calculus that you want to be familiar with. The first one is limits. Now, limits help you to evaluate a function. Let's say if
one of those,
f when x is equal to 2, but for some reason the function is undefined or we just can't do it.
Not a lot is happening
a
here.
Limit will allow you to see what happens as x approaches 2. And so limits
I guess somebody out there is a Beer King Reacts fan.
Approach a certain value. Now the second area of calculus
what you pay for, so this is what kind of reaction you're gonna get.
So what are derivatives? Well, basically,
thanks for keeping the channel alive at least.
That give you the slope of an original function at some value.
I can't even make this entertaining, even if I wanted to. It's just impossible.
The derivative of f of x.
There's no visual. It's just
now this function
words
here
and
will tell me
letters and shit.
Of this function at some x value. It will give me the slope of the tangent line. So derivatives are very.
I'm not here to learn this, folks. If you want to study this shit,
now the third area
do it yourselves.
Integration.
It ain't gonna help you win the lottery.
The opposite of derivatives. With integration, you're basically finding the area under the curve.
35 minutes of this shit.
Integration is very useful for calculating how much something accumulates over time. And what you need to know is that derivatives and integration,
this is what you told him to say.
For instance,
this is what
we said that the derivative of the function f of x is equal to f prime of x. So this is
if you can be learning this as you're watching it though, like write it down.
The integral of f prime of x is f of x.
I can't speak this language.
Is the antiderivative or the integral of f prime. So you can think of integration as finding the antiderivative. Now let's begin our discussion with limits. So let's say that
I like to have a limit break.
f of x is x squared minus, oh, that is a terrible looking 2. Let me do that again. So let's say it's x squared minus 4 over x minus 2.
For videos like this, the seal that you'll get is
f of 2. Can we evaluate the function at x?
I'm too tired.
Well, let's find out. So if we plug in 2, 2 squared is 4, 4 minus 4 is 0, and 0 over 0, what is that? Well, we can't figure this thing out, so that's indeterminate. Therefore, we can't evaluate the function.
I don't know, man.
And so this is
you do know I don't really pay attention to that type of stuff.
So if we can't find out the value of the function when x is 2, can we find out
is 2.
What the function will do as x approaches 2?
X is a Twitter.
So what happens when x is, let's say, 2.1? So if we were to plug in 2.1 into the function.
Well, if I wish I could see into the future, I would have brought a bunch of items to show off during this. I just got the same shit.
Now, what if we plug in a number that's even closer to 2?
I got the back scratcher, it's metal.
Well, if we do that, this will give us 4.01.
Alright.
So notice that as x gets closer and closer to 2, the value of the function gets closer and closer to 4. So thus, we can use a limit expression.
Where's the number 7 at?
So we could say that the
777,
limit
lucky number.
as x approaches 2 of x squared minus 4 over x minus 2, we know it's equal to 4. But to show your work, what you need to do is factor x squared minus 4.
There you
And when
go,
you factor it
folks.
using the difference
The
of squares method,
ultimate ball
it's x plus
games
2 times
championship.
x minus 2. And so we could cancel this factor. And so we're left with the limit
It's
as
thundering
x approaches 2
outside.
of x plus 2. So now we can use direct substitution. So we can replace x with 2. So this becomes 2 plus 2. And this gives us the limit,
2
which is 4.
plus 2, that's
So this tells us
right.
that as x gets closer and closer to 2, the y value, or f of x, will
Yeah.
approach a value of 4. So even though f of 2 does not exist, the limit as x approaches 2 of the function f of x, that exists, and that's equal to 4. And so make sure you understand that limits help you to see what happens to a function as x approaches a certain value. Now let's move on to number 2.
Number
Derivatives.
2 hasn't taken a shit.
So how can we find the derivative of a function? The most
I
basic
can't even
rule
say
we need
that
to know
word.
is the power rule.
Derivatives.
Of a variable raised to a
I think
constant,
I said it.
such as x raised to the n power, is n x raised
Why
to
don't
the n
you draw
minus
a
1.
pair of
So how do we
titties?
apply that?
I can help you do that.
Let's say
Circle,
if we want to find the
dot,
derivative
circle,
of
and a dot in the
x
middle.
squared. So in this case, n is 2. So it's going to be 2
Yeah.
times x raised to the 2
Are
minus
you
1,
drawing on your
which is
tablet?
1. So we get 2x.
No, you're just
If we
using
want to find the derivative of, let's say, x cubed,
I don't know, folks.
n is
just don't
3,
know.
so it's going to be 3x to the 3
Don't
minus
do
1,
drugs. And if you're in
which
school,
is
stay in
3x
school.
squared.
And don't break the law.
Now, if we want to find the derivative of x to the 4th power, it's going to be 4x raised to the 4 minus 1, which is 4x cubed. And so that's a
4x
simple
cube.
process in which you could find the derivative of a function.
Not everybody learns this
But now,
shit.
what does it mean? So we said that the derivative is a function that gives us the slope of the
I
tangent.
think everybody should be super
of some
intelligent
original
on this
function.
planet. But most of them
So
are
you might be
dumb.
wondering,
And there's
what
only a
is
select
a
few that's
tangent?
smart, which
So let's
proves
talk
that
about
somebody is
Let's say
playing
if we have
favorites.
some curve, and a tangent line is a line that touches a curve at one point.
Yeah.
Now you need to be familiar
A
with
blue
secant line.
arrow and a red
secant line
arrow.
Is a line that touches a curve.
Is it got a giant
points.
boner? Oh, he got a green one. That's Piccolo's cock.
So the slope of a tangent line is equal to the derivative
Tangent
of a function at
Oh
some
shit,
value.
I'm getting scared. The
To calculate
thunder.
the slope of a secant line,
It probably
you've done
fucking
this
knocked
before
this
in algebra,
video out
using
with electricity
this
and I'll have to
expression.
start it all over.
It's rise over run,
That would be a
y2 minus
bitch.
y1 over x2 minus x1.
I kind of want this
Now
video
let's
to
say
end now
that
because I
f
don't
of
want it to
x
get really bad out there.
is x cubed. Using the
X
power rule,
cube.
the first
Rubik's
derivative
cube.
is 3x squared. So let's say if we wanted to calculate the slope of the tangent line when x is equal to 2. So the slope of the tangent line is going to be
There are
f prime
probably
of 2,
like billions of
which is 3
videos
times
on
2 squared,
YouTube to choose
so
from.
it's 12.
Well, we
So
get
this
this
means that at
instead.
x equals 2, the slope is 12. So what does that mean? That means that as you travel 1 unit to
Means
the right,
fuck you. That's
the
what it
curve
means.
will increase by a value of 12. So every time you travel, or every time the x value increases by 1, the y value will increase by 12.
I don't even understand what he's
So
saying
that's what a
there.
slope of 12 means. Now let's draw a rough sketch of the original function x cubed. Now the graph doesn't have to be
I'm not even
perfect,
going to check the time on this. I know we got a
just good
long
enough
ass way to
for
go.
instructional purposes. And just to keep things simple, let's say at this point x is equal to 2. Now,
This might as well
granted,
be
the
an
graph is not drawn to
ASMR,
scale, so keep that in
a
mind.
real one.
Now what we're going to do is we're going to estimate the slope of the tangent line
The slope of the
using the slope of
fangulon.
the secant line. Now, to calculate the slope of the secant line, you need to choose 2 points. A point that's to the left of where you want to evaluate the slope of the tangent line, and one that's to the right. So this point is 2. We need to choose 2 points such that the midpoint of those 2 points is equal to 2. So we could use 1 and 3 for an example. We can use 1.9 and 2.1, or we could use 1.99 and 2.01. In each of those cases, 2 is the midpoint. But we're going to see what
Exciting, ain't it,
happens to the
folks?
slope of the secant line as the 2 points, as they get closer and closer to the slope of the tangent line.
If anybody's sticking around with me, you're a champ.
So first, let's calculate the slope on the interval from 1 to 3.
I'll give you a slope right here.
So we're going to use this form, y2 minus y1 over x2 minus x1. So y is the same as f of x. By the way, this is x1 and this is x2. So x2 is 3, x1 is 1.
Speaking of x, when's Mega Man X9 ever going to come out?
Function
it's been like 30 years and we still haven't seen it.
y1 is equal to the function when x is 1. So basically, to evaluate f of 3, we need to plug in 3 into that expression.
Fuck so you and your advanced alien fucking language.
3 to the third is 27, 1 cubed is 1, 3 minus 1 is 2. So we get 26 over 2, which is 13. So this is not a bad approximation for the slope of the tangent line. As you can see, 12 and 13.
I got a number joke for you. Why is 6 afraid of 7? Because 7, 8, 9.
So I'm just going to write this down on the bottom for reference. So now let's choose numbers that are closer to 2, like 1.9 and 2.1. So 2 is the midpoint. So it's going to be f of 2.1 minus f of 1.9 over 2.1 minus 1.9. So let's plug in 2.1 into that expression. So that's going to be 2.1 to the third power minus 1.9 to the third power. 2.1 minus 1.9, that's 0.2.
Yeah, boy.
So if you plug this in, you should get 12.01. And notice that this is a very good approximation to the slope of the tangent line. So notice that the slope of the
secant line. This is very similar to another video I reacted to. Or is this that same video? I don't remember. They're very forgettable.
Closer to 2. Now, what was that something that helped us to evaluate a function as x gets closer and closer to some value? If you remember, it's limits. So we need to incorporate a limit expression.
This guy really thinks a bunch of people is listening in on this.
That looks like this. So let's use limits to evaluate the slope of the tangent line. So x is going to approach
the end times are here, folks.
And it's going to be f of x minus f of 2 over x minus 2. Now f of x, we know it's x cubed. F of 2, if you plug in 2 into that expression, 2 to the third is 8. And you get this.
Anybody getting this so far?
We need to factor x cubed minus 8.
Anybody enjoying this?
So to factor differences of perfect cubes,
this is comedy gold.
It's a minus b times a squared plus ab.
Why don't you just sing ABCs instead?
So to factor x cubed minus 8, x is a, b is the cube root of 8, which is 2. A squared is x squared, ab is 2x, b squared is 4. So this is how you can factor x cubed minus 8.
Okay.
So now we have this. The limit as x goes to 2 of x minus 2 times x squared plus 2x
Man, it'd
plus
be
4
nice to have some hot-ass women in
over
here
x minus
with
2.
big titties and a real pussy.
So now these two factors will cancel. And now we can substitute 2 with x. So we have the limit as x approaches 2 of x squared plus 2x plus
You love
4.
to say X a lot.
And so it becomes 2 squared plus 2 times 2 plus 4. 2 squared is 4, 2 times 2 is 4. And if you add 4 3 times, it's the same as taking 4 and multiplying it by 3, which gives you 12.
What's the benefit of learning
And
this?
so we could use a limit process to find the
Because
slope
this is
of
a
the tangent line,
shitload of stuff to learn.
as well as just
What, just to
finding the
say,
derivative.
I'm
and plugging this in.
smart and I can talk that
So
way to
as you can
everybody
see,
and they wouldn't
the
get it.
derivative
And that makes you feel special.
is a
Because you
function
use big words and
that
numbers.
gives us the slope of the tangent line at some x value. And there's multiple ways in which you can calculate the slope of the tangent line.
I
You can
want some
estimate it
Wolverine
using the
claws.
slope of the secant line, or you
Shing,
can
that's just
calculate
one.
it using a limit process. So I wanted to connect limits with derivatives in one video.
Gotta wake
Now
myself
the next
up.
area
Can't fall
is
asleep.
integration, which is equivalent to
Here's some
anti-differentiation.
scissors, yeah.
As we said before, it's the process of finding the antiderivative. Now, if you recall, we said that
I'm creating me some actual Wolverine
of x to the
claws.
fourth is
Here we
4x
go.
cubed using the power rule.
Yeah, Wolverine.
Well, the integral
Yeah.
of 4x cubed
Yeah.
should give us x to the fourth. And here's the formula for finding the antiderivative integral.
Integration.
So you're going to add 1 to n and then divide by that result. And you're going to add some constant of integration. The derivative of any constant is 0. So
You might as well
integrate,
just
you
try to
always have add a
learn
constant to your
Japanese
expression.
or Spanish. How does
So this
people
is
have
gonna
time
be
to fucking learn that
4x
shit?
to the 3 plus 1
I studied a
divided by
few
3 plus 1.
words and
So that's 4x to the 4th
I forgot
over
them.
4. And let's not forget to add plus c. And so as you can see,
C as in
we get
cunt.
x to the 4th plus some constant. So integration is the opposite process of differentiation. So you can call it
I'm trying to think
anti-differentiation.
what to say next, folks.
Now I want to take a minute to compare derivatives and antiderivatives, or integration, side by side.
Yay!
Just so you could see the key
Derivatives.
differences between the two.
Integration.
So when dealing with derivatives, you're looking for a function that will tell you the slope of the tangent line, which touches the curve at one point, at some x value. So derivatives are useful for calculating the instantaneous rate of change. Now, when dealing with integration, this will help you to determine how much something accumulates over a period of time. Whereas derivatives will tell you how fast something changes per unit of time. So integration is very useful for calculating the area under the curve. So when dealing with derivatives, it will give you the slope of the
Rates
tangent line,
of
which you can
change.
calculate it by
Slope
dividing
equals
y by x.
triangle
To calculate the
y,
area, you
triangle
need to
x,
multiply
and a
y by
equals
x.
x,
So notice the
y.
difference.
You said yx, it's
So
x,
in its
y.
simplest form, when you're differentiating, you're dividing the y values by the x values. Whereas when you're integrating,
your face is
you're
that.
multiplying the y values by the x values. And multiplication and division, they're opposite processes. And that's essentially what you're doing when you're differentiating and integrating. Now, of course, it's a little bit more
Are you a
complicated than that,
professor?
but that is the gist of it. Let's consider this problem. So we have a function, a of t,
Okay, we got
which is
something different
0.01
going
t squared
on.
plus 0.5t plus 100. And this function represents the amount of
Yeah.
water in gallons that is inside a tank
Calculate
at
the
any
amount
time
of
t,
water.
and t
It
is in
should be
minutes.
beer.
So what we need to do is calculate the amount of water at the following times.
Oh, here we go. He's back to doing this
So when
again.
t is 0, when it's 9, 10, 11, and 20.
You skipped
So go
12.
ahead and do that when you get a chance. So feel free to pause the video.
Feel free to pause the video, folks,
And so here is our original
because
function.
I'm not going
It's
to.
0.01 t squared plus 0.5 t plus 100. So let's go ahead and plug in 0. If we plug in 0, it's going to give us this value, which is 100. Now, if we plug in 9,
No, he's tapping on a keyboard.
it's going to give us 105.31.
Was
Now
you
let's
at
plug
using
in
a
10.
calculator?
So it's
Jesus
going to be
Christ,
106.
folks. What the fuck?
And if we plug in 11, we're going to
People
get
like their
106.7.
videos. They like exciting
Now let's plug in
videos.
20.
They like boring videos. Everybody's got their own taste.
So you
No,
should get
let me change that.
114.
Rephrase it. People like good
Now
reactions.
keep in mind,
People
T
like
is in
shit
minutes
reactions and boring
and A of
reactions.
T is in gallons. So let's focus on part B.
Which one does this
How
category
fast
it
is
falls
the amount of water
into?
changing in a tank when T is equal to 10?
Yeah.
So do we need to find the derivative or do we need to integrate? How fast is the amount of
I
water
gotta move
changing?
around a little bit
Are
because
we dealing
my
with
eyes are
rates
trying
of
to close
change
on me.
or accumulation? So because we're dealing with rates of change,
Race
we're
of
dealing with
change. What are
derivatives.
you talking about?
So let's begin by finding the first derivative, a prime of t. So what is the derivative of t squared? So using the power rule, it's going to be 2t
Why don't you draw a
to the 2
dick
minus 1,
with
which is
balls?
2t to the first power, or simply 2t.
Do something.
Now what is the derivative of t, or t to the first power? It's going to be 1t raised to the 1 minus 1, which is 1t to the 0. Anything raised to the 0 power is 1. So this is going to be 0.5 times 1. Now what about the derivative of a constant, like 100? The derivative of any constant is 0. If you were to use the power rule, this would be 100 and then times 0, because you need to bring this to the front, and then it's going to be t to the 0 minus 1. 100 times 0, the whole thing
He's
is 0.
still going at it, folks.
So therefore, the derivative function is going to be a prime of t, which is 0.01 times 2, that's 0.02
Who the fuck
t
is this for?
plus 0.5.
College kids?
So this is the derivative.
I
It's going
guess
to tell
so.
us how fast the amount of water is changing in a tank at any time t. So we want to find out how fast it's changing when t is 10. So that's
Should I
0.02
check the
times
time,
10
folks?
plus
Or wait a
0.5.
little bit? Let me check
0.02
on here.
times 10, that's 0.2. And 0.2 plus 0.5, it's 0.7.
Time's going really
So
slow.
this tells us that
I ain't going to check
the
on
amount of water
here
is
yet. I'll
changing
just wait a few more minutes.
by 0.7 gallons every minute when t is 10. Now, if we were to graph the original function, this value will represent the slope of the tangent line.
The
So how do we know if our answer is
slope
correct?
of
Well, one way to
happiness.
determine that is to calculate the slope of the tangent line by approximating it using the slope of the secant line. Now, it's important to understand that the slope of the tangent line represents the instantaneous rate of change. It's the rate of change exactly when t is 10. That's at 1 point. The slope of the secant line represents the average rate of change, which you can calculate it using 2 points.
Average.
So to calculate the slope of the secant line, or the average rate of change, our 2 points will be 9 and 11, because 10 is the midpoint
I could be
of
reacting
9
to
and
something
11.
else for
So
somebody,
remember,
but
to calculate the
here
slope,
we are.
which is associated with derivatives, you need to divide the y values by the x values.
You can
So
revive,
t would be
or
along
yeah,
the
your dick
x-axis, a of
values or
t would
some
be along the
shit.
y-axis. So a11 is a y value, and the same is true for a of 9. 11 and 9, those are x
Where's
values,
the
or t
titties?
values.
Where's the pussy?
So at 11, it's 106.71. And at 9, it's 105.31. 11
There
minus 9
was
is
no
2.
saving this one, folks.
So if we were to plug this in
It was
to
inevitable.
a calculator, this will give us 0.7.
Fuck you, cars going by
So in this
making loud
case, the
noises, you
slope of the
piece of
secant line
shit.
is the same as the slope of the tangent line.
Slope of your finger line and shut the
Now,
fuck
another
up.
way in which you could see the answer is by looking at the table.
The head of
So
the
remember,
table.
this is the amount of water that changes every minute. So 0.7 gallons per minute tells us
I
that
don't care
every
much
minute
about
the
water.
amount of water
Beer
in a
is where
tank
it's
is
at.
increasing by 0.7 gallons. And so looking at the table, going from
All
9
right, I'm going to
minutes to
check the
10 minutes,
time.
in 1 minute,
Here we
the
go.
increase in the
3,
amount of water
2,
was 0.69
1.
gallons. And going from
Okay,
10
we're
to 11 in the
25,
next minute,
26 minutes
the
in.
increase in the amount of water
And yeah, 26 is still
is
got.
0.71
Yeah.
gallons. So if we were to average the changes from 9 to 10 and 10 to 11, it will give us 0.7
It's more than I
gallons per
thought.
minute.
Anyway.
And so hopefully this example illustrates how derivatives can be used to calculate an instantaneous rate of change. It can tell you how fast something is changing per unit of time. Now let's work on this problem. The rate of water flowing in a tank can be represented by the function
I really
R of
don't
t,
give a
which is equal to
fuck.
0.5t plus 20, where R of t represents the number of gallons of water flowing per minute, and t is the time in minutes.
And
So here's the question.
T.
How much water will accumulate
How
in the
much
tank
wood
from
could a
t
Chuck
equals
wood
20
cut
to
Chuck
t equals
wood?
100 minutes?
Yeah.
So should we use integration or differentiation? Remember, derivatives will help you to find the rate at which something is changing. But integration is the process by which you can determine how much something accumulates over time. And so this is an integration problem. Now we can calculate the net change in the volume of water using a definite integral from a to b of the function r of t dt. The difference between a definite integral and an indefinite integral is that a definite integral have the lower limit and the upper limit, and it gives you a number. Whereas the indefinite integral, which is on the bottom, this gives you a function.
Good
It doesn't give
shit
you a
right
number.
here, folks.
So make sure you understand that key difference between
This will
definite
help you
integrals
become a
and indefinite
fucking
integrals.
genius.
So going back to this problem, to calculate how much
Y'all
water
been
will
writing this
accumulate in a tank
down and
when
studying
it use 80
hard.
minutes, we can see that A is 20, that's the lower limit.
That's a capital
B is
2
100.
S's there.
R of t is 0.5t plus 20. So let's go ahead and find the antiderivative of 0.5t and 20. So the antiderivative of t to the first power is going to be t to the second power divided by 2. Just add 1
I
to the
think I'll check
exponent
the time
and then
again.
divide by that result.
28
20,
minutes in.
You can imagine 20 as being 20 t to the 0. So if you add 1 to 0, you'll get 1, and then divide by that number. And then we're going to evaluate the result from 20 to 100.
I guess I can, where the fuck it
So
go?
the first thing we're going to do is plug in 100. So it's 0.5 times 100 squared divided
There
by
it
2
is.
plus
Check out my
20t,
back
20 times
scratcher.
100.
It's metal.
And then
It
we're going to plug in
extends.
20 into
I
this
think I might
expression.
use it on my back.
So it's
See if
minus
it feels good. Oh, yeah.
0.5 times 20 squared
Man,
divided
I
by
wish a
2
hot woman was
plus
scratching my back with her
20
nails.
times 20. So now let's work out the math.
How
100
about
squared
let's
is
not?
10,000,
Let's just call it a day.
and 10,000 divided by 2 is 5,000. Half of 5,000
Videos
is
like this do
2,500.
not need to be this
And
long.
then 20
Oh,
times 100
fuck.
is 2,000.
I can be sharp.
Here we have 20 squared. So 20 times 20 is 400. Divided by 2, that's 200. And then half of
Just
200,
a
that's
bunch
100.
of numbers.
And
We
here we
got
have 20 times
calculators
20,
to
which
help
is
us out. We
400.
really don't have to sit there and do
So now we
whatever.
have 4,500 minus 500. So
You
the net
think you're better
change
than me because you
should
can
be
speak
4,000.
Japanese?
So from
I'm the
t
king of
equals
all
20
beers,
to t
man.
equals 80, the tank will gain 4,000
Oh
gallons
damn.
of water. Earlier in this
You
video,
drink a lot of water, you
we
must
said
got a
that
water
integration
fetish,
is
which is a
associated with
disguise. It's
finding the
probably a
area
piss
under the
fetish.
curve. So what we're going to do is we're going to graph this function. So the y-axis corresponds to r of t, the x-axis is t.
Fuck me sideways, man. What
Now
the
when t is
fuck?
0, the y value will be 20.
This
This
is
is the point
driving
intercept.
me to a complete
Now the points of
coma.
interest are 20 and 100. So when t is 20, if you plug it into this expression, 0.5 times 20 is 10, plus 20, that's 30.
Wait, what? What are we
So we
talking?
have this point.
I don't
So
even.
r of
I
20
don't even know
is
what the
30,
fuck this was
and
said.
r
I
of
can't
0,
hear you.
let me use a different color, is 20. Now what about r of 100?
Do ASMR. This
So
is basically
0.5
an
times 100
ASMR,
is 50, plus 20, that's going to give us 70.
but not a very entertaining one.
So r of 100 is
It's
70.
just a normal one for people that
Now
want
we
to
can
fall
draw
asleep.
a straight line. So our goal
Straight line
is
is
to
where I
calculate
go.
the area under the
If y'all
curve
want to go
from
to the gay
20 to
line
100.
route, that's up to you. It's your choice.
This area, let me shade it, represents the increase in the volume of water that's already
I'm
in the
gonna check the
tank.
time again.
It doesn't represent the
All
total
right,
amount of
we're
water
about
that's in a tank at 100.
32 minutes in. A
It
few
simply
seconds. Here we
represents
go. 32.
the change in the volume of water
We're almost
in those
gone.
80
Done.
minutes.
We're almost.
So
My
let's
brain's
calculate
almost
the
gone.
area under the curve.
I don't know if
Now
they can
using
make it or
geometry,
not.
it's helpful to break this region into a rectangle
This
and a
video's
triangle.
definitely forgettable. I probably won't
And so
remember
to
it.
find the
I'll
area, we
remember
need
the
to multiply
suffering
the x values by the y
and
values.
some flashing
The area of a
lights.
rectangle is length
Maybe a
times
few
width.
numbers. I don't know.
So the length is the difference between 100 and 20, which is 80. The unit for this is 80 minutes. And the height
Feels like this has been
of the
about 80
rectangle is 30.
minutes.
And the unit for that is gallons per minute. So if you multiply
What are you going to do with
minutes
that many
by
gallons?
gallons per minute, the unit
Probably
minutes will
got gallons of
cancel, giving
jizz
you
in your
the unit
tank.
gallons. So 80 times 30. 8 times 3 is 24. And then if we add the two zeros, that will give us 2400. Now let's focus on the triangle. The area of a
Illuminati
triangle is
triangle.
1/2 base times height. In this case, we could say the base is associated with the x-axis, the height is associated with the y-axis. So whenever you're dealing with integration, you're going to be multiplying x by y. When you're dealing with differentiation, you're dividing y by x. Now, the base of the triangle is still 80. It's still the difference between 120. But the height of the triangle is the difference between 70 and 30.
33
So it's 40.
minutes in.
Now, 80 times 40. 8 times 4 is 32. And if you add the
Just a
two zeros,
few
that's
little
3200.
minutes
But we need to
left.
take half of it because we no longer have a rectangle. We have a triangle. And a triangle is half of a rectangle.
It's a
So
pyramid.
that's why it's a half base times height. So half of
Except
3200
yours looks a
is
little
1600.
off.
Thus, if we add 1600 and 2400, that's going to give us our answer of 4000. And so that's how much water was accumulated in the tank in those 80 minutes. it's 4,000 gallons of water.
Name
It doesn't
another
represent the
reactor
total
that
amount of
does
water in a
this,
tank,
what I'm doing.
but it represents the change in the
They lose
volume
their
of water
mind.
in the last 80 minutes. So that's basically it for this video. So to review, just remember
Okay,
limits
finally.
allow you to evaluate a function when x approaches a certain value.
Oh, it's not done yet. He said that was.
Derivatives
You
are
made me think it was
functions
over, you fucking lying piece
that
of
allow
shit.
you to calculate the instantaneous rate of change of a function at any instant of time.
I'm gonna keep
And
looking at the
remember, the
time.
instantaneous rate of change is equivalent to the slope
Come
of
on,
the
hit that
tangent
35 mark.
at any instant of time.
35.
You
Yeah,
can
we got 1
approximate
minute and 20
the slope of
seconds
the tangent
left,
line using the slope of the
I
secant line,
believe.
which is equivalent to an
Let's just
average
go
rate of
to some
change
credits or
in
something that
2
I can stop
points.
it earlier.
Finally, we have integration, which is a process that allows us
This
to
was it.
determine how much
One more
something
dance.
accumulates over time. And we can find that value by evaluating the definite integral or by calculating the area under the curve. So these are the 3 fundamental concepts taught in a
There
typical
you go.
calculus course. So make sure you understand the basic idea behind limits, derivatives, and integration.
Yeah.
And that's basically it for this video. So for those of you who haven't done so already, feel free to subscribe to this channel and don't forget to click on that notification bell. Now I'm going to post some links
Fucking
in
stop
the
it already.
description section of
Shit.
this video with more problems on limits, derivatives, and integration,
Refuses
so
to
you can
stop.
get more practice with that. And also check out my new calculus video playlist because it has
No, I'm
specific
good.
topics in
I'm gonna
calc that
watch
can help
porn
you
instead.
if you're taking that course. So that's all I got for this video. Thanks again for watching.
So there you go, everyone. If y'all want to watch the original video, the link is in the description. Go check it out and shit. And I'm getting the fuck out here, so yeah. My name is Billy Bob Tanley, and I approve this message.